to the very first episode of Advantest Talk Semi. I'm your host, Keith Schaub, Vice President of Technology and Strategy for Advantest. In this inaugural episode, I'm joined by two veterans of the semi industry. Ira Leventhal, Advantest Vice President of Applied Research and Technology, and Alan Hart, Senior Director of R&D. And we're going to talk about the ever-changing and converging world of technology and the important role that semiconductors, and more specifically, semiconductor test, play in advancing our lives. I can say with confidence that IC test, which was once seen as a bottleneck to the production flow, today is largely viewed as a critical enabler, giving chip manufacturers unprecedented control over the fabrication of their highly complex devices. As our reliance upon these devices becomes ever more important to maintaining the infrastructure of society, the changing role of test as a competitive advantage is being recognized throughout the semiconductor industry. As technologies converge on Industry 4.0 with smart manufacturing, autonomous vehicles, smart medical, smart homes, AI, and more, IC test has become crucial to the reliability and performance we demand in today's world. So Alan, let's start with you. I'd like to start with, how have you seen IC test from when you first started as an engineer to today? How has it changed?
Good question, Keith. So a couple things. First of all, I would be dating myself if I told you exactly what a tester looked like when I started, but they were approximately the size of a refrigerator, and they had like 4 to 6 channels of test capability, and so that gives you an idea of the level of integration, whereas today you can get thousands of channels of IC test capability in the same form factor, and that's just from an integration standpoint. But maybe more importantly, what has happened over time is that test has gone from a function of separating the good and the bad amongst the die on a wafer or in a package to actually providing more value to enabling those chips to perform the function that they were designed to do. A simple example being on a non-volatile memory, testers actually make the non-volatile memory work by aligning the sense amplifiers. Maybe in an RF circuit, what they do is the tester will actually calibrate the RF circuitry on the chip, allowing it to actually perform to the performance levels it was specified for. So those are just a couple of simple examples.
You know, I remember when, back in the days of Hewlett-Packard, we had RF-centric testers, we had digital-centric testers, and mixed-signal-centric testers. And as the device integration happens, so too must the test integration follow. So that follows very closely to what you were just describing.
Yeah, way back in the day, most testers were designed in-house by the company who was actually using them. And it was a mixture of standalone box instruments that were integrated together with a lot of cabling and some homebrew software to wrap around them and perform the functions that they did. And it wasn't until somewhere in the kind of mid to late 1980s before there was actually a lot of capability that became commercially available, and you had more of what you see today in test systems available.
Yeah, that's great. So Ira, you also have a memory background. What are some of the things that you've seen transition over your career?
Well, I think one of the key things is that I've definitely seen a very big change in terms of the overall perception of test. Whereas back in the, quote, old days, the test was looked at as something that we just had to do to, as Alan said, make sure that the parts were doing what they were supposed to do. And Keith, as you mentioned, the testers were, had not gone through this period of convergence. And so what we've seen since then is that the testers themselves, in order to keep up with the complexity of the devices, they've become very complex. And we've seen our customers look at now, how can we get the most out of these machines? Whereas we always used to hear, what can we do to decrease test time? Every year we were expected to chop another 20% off test time. And that's how people were looking to get the most out of the equipment, or how can we stretch it out to use it for 10 years rather than 5 years. And now it's really become, what can we do to get more out of the tests that we are doing? We're hearing our customers say, we're not looking to just decrease test as the goal. It's how can we get the most out of it? How can we take our test budget, gather as much information as we can, increase our quality, increase our yield? The overall perception has just completely switched. And I think the customers are looking at it like, we're spending a lot of money on these testers. There's a lot more we can get out of them than just being a gate to whether these parts are passing or failing.
Alan, as you mentioned, back in the day, data was more of an afterthought. They were really just measuring versus some performance specs, and there wasn't much done with the data. It was just used to decide to either pass the part or fail the part. How are you seeing that change from what was done in the past versus what is done today?
So you're correct. In the past, data would be presented in some kind of a printed output from a machine. Today, data is something that operates across the spectrum of manufacturing. And so data becomes this value-added insert, if you will, in the manufacturing process to help the customer or the manufacturer or the end user have a greater understanding of where that device has been and what has caused it to operate the way it does. And that allows much more value in the manufacturing chain than it did 20 years ago.
So we know in Industry 4.0 with autonomous vehicles, for example, that testing is super critical to the success of that industry. If you have a car with a chip that isn't properly tested, someone can die. I mean, lives are at stake. What we've seen as a general trend is as the technology advances, so too do the risks, because we become more reliant on that technology, and also we need to trust that technology even more so because we are reliant. So this just keeps compounding and adding the importance of test to the equation. And that leads to why the data is so important and how are we going to extract the maximum value for the data. So maybe, Ira, you have some comments on that. What do you think about that?
The fact that the devices have become so complex and the applications, they are mission critical applications that the devices are being used in every day. And this has been a big change from where you were looking at like things like space travel, medical applications as being the mission critical types, and now it's self-driving cars and the servers that need to stay running 24/7. There's an everyday dependence of a large portion of the population on these devices, and so the complexity demands that we use test in its fullest extent to be able to make sure that the quality levels are being achieved. When you look at going from 0 defects per million to measuring defects in parts per billion, it's really challenging, because it used to be that unless there was a defect that was being seen over and over again on the tester, the defects were just considered to be random. The parts were thrown in the dog pile, and we never saw those parts again unless they started seeing a certain type of error over and over again. But in order to get to measuring defects in parts per billion, every single defect, every single failed test needs to be understood as best as possible in terms of why it's happening. And so the data becomes super important in terms of being able to infer as much as we can out of the data.
So let's talk a little bit about AI. One of the things we're seeing in the industry is just the explosion of data. And the data is getting so large that human ability to make sense of that data is coming into question. We're just not able to examine and analyze the data fast enough, whereas AI can come in and do some amazing things with that data. So how are you seeing that, Ira?
Well, the development of the AI capabilities, machine learning, and so on, it's been really fascinating to me to see this all come together, especially over these last 5 or 10 years. Back in the 90s, I was looking at what we called back then neural networks. That was before all of the fancy names came about for artificial intelligence, machine learning, and so on. And at that point, I was working on developing a system that would extract spice models for semiconductor devices. And a lot of effort was going into tailoring the equations for these spice models. And I thought, hey, these neural networks, this looks like a really cool technology. Why not collect a bunch of data off the wafer? I'll train the neural network to be able to model each particular device in the wafer, and then can build up a model from there in terms of the overall circuit behavior. And so I worked with a team at Stanford that was developing a neural network capability, and I looked at applying this to this semiconductor device modeling. And it actually worked. It worked great. The only problem was that it was incredibly slow. It was not something that could be scaled up in terms of modeling any kind of a large circuit, because the capabilities just weren't there to be able to apply this AI machine learning neural network capability on any kind of a large scale. We didn't have the computing power. We didn't have the availability of the large amounts of data. We hadn't developed the algorithms to the point where they could really be applied effectively. So it became more of a kind of a nice science project. And I thought, wow, maybe someday this is something that we can really use on a larger scale. And it's been really amazing to see it all come together over the last 5 to 10 years. And the way that it's been taking off and applied to all different types of problems. So I think it's something that the algorithms are going to continue to get better. Of course, the computing power is going to continue to increase. The availability of the data is such that the scale that we're going to be able to apply this technology to is just going to continue to grow and grow.
Yeah, and it's interesting you mentioned that it just worked back in the 90s. So I've seen time and time again where we're talking about AI, and a lot of people think that it just suddenly appeared and now it's solving all these problems. And to your point, it's been around for decades. The challenge has been it wasn't fast enough and it couldn't scale. So it could be and was used in limited capacity, but now with just the cost to compute essentially down to zero, we're able to take advantage of all of these methodologies that have been on the books, let's say, for the last couple of decades. Alan, thoughts on this?
Sure, Keith. If you think about what we can do now, as you say, with the essentially free computing capability that is out there, the data has buried in it insights that we never would have been able to extract in years past, just because of that ability to compute wasn't there. Just a quick example of something that is maybe a little bit different for non-technologists and why AI can make a better experience for them. So a few years ago, a family member bought a new phone. And what's the worst thing that can happen to a family member with a phone? The phone breaks, right? Your world is shattered instantly. You can't do a text message to your friends, and it's a really bad day. And that phone broke after 6 months, and it was a major manufacturer. And so a family member, in a hurry, went back to the phone store and got another phone, but she says, I don't want a phone from that manufacturer. I want a different company's phone. And so she got a new phone, and now she is a customer for life from the new company, or ever again from the old company. And the root of this story is the understanding of what may have caused the phone to fail was already in the data that was available, but the AI and the reliability extraction had not been available at the time that phone was manufactured. And so today, through the application of AI, we can make products that are better, and as a result, we can win customers for life as we apply that.
Alan, thanks for that example, and I think we can all relate to the phone example, as most people have one or more phones. I think this also highlights how test escapes are more costly than one might imagine. People talk about tests and how much it costs, but if you miss the test escape, you can lose your customer, and you can lose your customer for life. And I've seen some estimates where a test escape is 100 to 1,000 times more expensive than the actual test itself. So with that, I'd like to thank our two guests, Alan and Ira, for joining us on our inaugural debut as we took a walk from then to now in the test industry.
You're welcome, Keith. It was a pleasure to be here.
Thanks, Keith. My pleasure to talk with you about tests this morning.
Thank both of you. Okay, that tone means it's time for Junko's top 3 takeaways. I'm joined by Junko Nakaya, who is part of Advantest Global Marcom team and responsible for many of the trade shows and events worldwide. Junko, welcome. I understand you attended this year's Consumer Electronics Show. How'd it go?
Hi, Keith. Yes, indeed, I attended CES this year, which was completely virtual, so it was quite different, but it was very convenient and affordable. A lot of cool things I saw. Let me give you my top 3. So my number 3 is home appliances with AI, like washers and dryers that can sense fabric texture and set the right cycle for you, or a smart robot who picks up dirty dishes and load them up to the dishwasher. Wouldn't it be nice to have one of those at home, Keith?
The robot actually clears the dishes from the table and loads it into the dishwasher?
Yes.
And all of that without an allowance?
Yep, that's right.
I guess I'm going to have to talk to my son about that one. All right, what's number 2?
All right, my number 2 is, this is a funny one, but it's a smart wellness toilet. So when you go to your bathroom, this smart toilet can measure your key output. That's how they called it. And they send a health report to your phone. Also, it can suggest better menus for you, depending on your, the key output.
So I get a menu selection based on my key output. I think it's best we move on before I say something that I regret.
All right, will do. All right, so my number 1 key takeaway from CES 2021 is the autonomous flying car. So this is still just a concept, but someday in the very near future, you can hop into this little pod, which looks like a small helicopter without a tail, and it just flies you to wherever you want to go without any driver or operator inside it. So this is something out of a sci-fi movie, but it's becoming a reality. So I thought this was very cool.
Yeah, that's very cool. But I've been seeing that since I was 5 years old in popular science magazines, and I think everyone's still waiting for that. But yes, looking forward to the day when we can just walk outside and pop into a pod and fly off to wherever we need to go.
Yeah, that's true. I'm looking forward to it too. Well, that's my top 3, but I have one honorable mention, which is solar-powered electric vehicles. So Keith, these are cars, SUVs, and even trucks that are actually wrapped in solar material. So they can just keep charging themselves as long as they are under the sun.
Yeah, but that means now we need skylights in all of our garages.
That's true. All right, to wrap it up, my main takeaway from CES was that this is truly the age of technology convergence. So all the advanced technologies like 5G and AI are actually being used in everything and everywhere, from our phones, TVs, and cars to medical equipment, factories, and beyond.
And I bet another takeaway is that you are hoping next year's CES will be live.
Yes, that's right. So Las Vegas, here I come. Thank you, Keith.
Thank you, Junko. Okay, to round out this episode, Annalicia is here with some Advantest updates. Annalicia, take it away.
Thanks, Keith. This year, the Advantest Voice Developer Conference is going virtual for the first time ever on June 21st through the 23rd, with a workshop day on June 24th. We have over 70 presentations planned, a technology kiosk showcase, and a partners expo. Registration has opened on March 30th. To learn more, please visit the Virtual Voice website at voice.advantest.com. Also, don't forget to follow Advantest on Twitter at Advantest_ATE and on Facebook at Advantest America. And Keith, that's the latest.
Thanks, Annalicia. We look forward to seeing everyone at Virtual Voice in June. Well, that wraps it for this episode. Thank you for listening. If you haven't already, please subscribe to our podcast. I'm Keith Schaub. Until next time, when Advantest talks Semi.